Have you ever looked up at the night sky and wondered if those stars have always been there? For thousands of years, humanity believed they were eternal, unchanging lights decorating the heavens far beyond our reach and impossible to understand. They seemed so distant that uncovering their secrets felt like an impossible dream. After all, how can you study something you can never touch? But hidden inside the light of every single star is a message that has been traveling across space for millions, sometimes even billions of years. A message so extraordinary that it tells us what stars are made of, how they live, how they die, and ultimately, how they are born. The incredible part is that we learned all of this without ever leaving Earth. Ever since the earliest civilizations, people have been fascinated by the stars. As darkness falls and thousands of tiny lights begin to fill the sky, it's almost impossible not to feel a sense of wonder. Ancient philosophers searched for answers using only logic and observation. Around 450 BC, the Greek philosopher Anaxagoras proposed that the stars were giant burning stones glowing with unimaginable heat, so incredibly far away that their warmth could never reach us. It was a bold idea for its time, and surprisingly it contained a small piece of the truth. But not everyone agreed. Just a century later, Aristotle argued that the stars couldn't possibly be made from the same materials found on Earth. Everything around us changed, aged, and eventually disappeared, while the stars seemed perfectly constant. Night after night, year after year, they appeared exactly the same. To Aristotle, this meant they had to be made from a mysterious heavenly substance called ether, something entirely separate from the world we knew. His belief became accepted truth and remained largely unquestioned for nearly 1800 years. Everything began to change as humanity's understanding of the universe slowly evolved. Astronomers eventually realized something that completely transformed our view of the night sky. The stars weren't moving around Earth at all. Instead, it was our own planet spinning on its axis while orbiting the sun, creating the illusion that the heavens revolved around us. Then, in 1572, something happened that shook the foundations of astronomy. A brilliant new star suddenly appeared in the constellation Cassiopeia. It became one of the brightest objects in the night sky, dazzling everyone who saw it. For months it remained visible before slowly fading away until it vanished completely. Today, we know this wasn't a new star at all, but a supernova. The catastrophic explosion marking the death of a massive star over 8,000 light-years away. But to the people of that era, the event proved something astonishing. The stars could change. They weren't eternal after all. Soon, another invention would revolutionize everything, the telescope. For the first time, distant points of light transformed into real worlds filled with incredible detail. Planets revealed mountains, craters, moons, and swirling storms, while astronomers realized that the stars were far more distant than anyone had ever imagined. They weren't tiny lights attached to a crystal sphere surrounding Earth. They were enormous suns scattered across an unimaginably vast universe. Suddenly, the boundary between heaven and Earth began to disappear. If the stars were distant suns, perhaps the same natural laws applied everywhere. In 1687, Isaac Newton confirmed exactly that. His law of gravity explained not only why apples fall from trees, but also why the moon orbits Earth, and why the planets travel around the sun. The universe wasn't divided into separate realms governed by different rules. Everything, from the smallest object on Earth to the largest celestial body in space, followed the same universal laws. Yet Newton unknowingly laid the foundation for an even greater discovery. While experimenting with light, he demonstrated that ordinary white sunlight wasn't truly white at all. By passing it through a glass prism, he revealed that it separated into every color of the rainbow. At first glance, it seemed like a beautiful curiosity, but hidden inside that colorful spectrum was one of the greatest secrets in astronomy. In 1802, English chemist William Wollaston looked more closely at sunlight and noticed several thin dark lines interrupting the rainbow. Assuming they were simply natural divisions between colors, he paid them little attention. But those faint lines were far more important than anyone could have imagined. Just over a decade later, German instrument maker Joseph Fraunhofer built a far more precise instrument capable of studying light in incredible detail. When he examined sunlight again, he didn't find just a few dark lines. He found hundreds of them, each appearing in exactly the same position every single time. It looked almost like a barcode hidden within the light itself. Fraunhofer carefully recorded these mysterious patterns, but no one knew what they meant. The universe seemed to be hiding a code that no human could read. The breakthrough finally arrived in the 1850s when two German scientists, Robert Bunsen and Gustav Kirchhoff, began experimenting with heated gases. They discovered that every chemical element interacted with light in its own unique way. When light passed through a gas, atoms absorbed very specific wavelengths, leaving behind dark lines in the spectrum. When those same atoms became energized, they emitted bright lines at those exact wavelengths. Every element produced its own unmistakable pattern, like a fingerprint that could never be duplicated. Suddenly, the mysterious lines in the sun's light made perfect sense. They weren't imperfections or random markings. They were signatures left behind by the atoms inside the sun itself. This discovery changed astronomy forever. For the first time in history, scientists could determine what distant stars were made of without ever visiting them. By comparing the spectral fingerprints created in laboratories on Earth with the light arriving from stars across the galaxy, astronomers realized that the same elements found on our own planet also existed throughout the universe. Hydrogen, helium, iron, calcium, sodium, these weren't unique to Earth. They were the building blocks of the cosmos itself. A question once thought impossible to answer had suddenly become one of science's greatest triumphs. In 1862, English astronomer William Huggins became one of the first people to attach a spectroscope to a telescope, allowing him to study the light of distant stars in extraordinary detail. Every star he observed revealed another piece of the universe's story. Humanity was no longer simply looking at distant lights in the sky. We had learned to read the messages hidden inside them. Those tiny points of light, once believed to be forever beyond our understanding, had become open books waiting to be explored. And as astronomers continued decoding the language of starlight, they uncovered even greater mysteries, discovering not only what stars are made of, but eventually revealing the extraordinary process by which they are born, evolve, and shape the very universe we call home. But knowing what stars are made of only answered one mystery. A far greater question still remained. If stars aren't eternal, then where do they come from? How does nature create something so massive, so powerful, that it can shine for billions of years? The answer begins in one of the coldest and darkest places in the universe. Scattered between the stars are enormous clouds of gas and dust known as nebulae. These clouds may appear empty, but they contain the raw ingredients for future stars. Most of this material is hydrogen, the simplest and most abundant element in the universe, mixed with helium and tiny grains of cosmic dust left behind by previous generations of dying stars. At first, these clouds drift quietly through space for millions of years, seemingly lifeless. But appearances can be deceiving. All it takes is a small disturbance, a nearby supernova explosion, the collision of galaxies, or the gentle pull of gravity itself, to upset this delicate balance. Once gravity begins to take control, everything changes. Tiny regions within the cloud become slightly denser than the surrounding gas. Those denser pockets pull in even more material, growing larger and heavier with time. As more gas falls inward, gravity becomes stronger, accelerating the collapse even further. Slowly, what was once an enormous cloud begins shrinking into a compact sphere. During this collapse, something remarkable happens. The gas doesn't simply pile up, it becomes compressed. And whenever matter is compressed, it heats up. The deeper the collapse continues, the hotter the core becomes. Temperatures climb from hundreds of degrees to thousands, then millions. At this stage, the object isn't yet a true star. Astronomers call it a protostar, a stellar embryo hidden deep inside its dusty cocoon. It continues feeding on the surrounding gas, growing larger while its core becomes increasingly hotter and denser. Eventually, the temperature at the center reaches an unimaginable 15 million degrees Celsius. Under these extreme conditions, hydrogen atoms begin smashing together with such incredible force that they overcome their natural repulsion. They fuse into helium, releasing staggering amounts of energy in the process. This moment changes everything. Nuclear fusion has begun. A new star is born. The energy produced deep inside the core pushes outward, while gravity continues pulling inward. These two forces reach a perfect balance, allowing the newborn star to remain stable for millions or even billions of years. Every ray of sunlight that reaches Earth today began its journey through this process inside the sun's core, where hundreds of millions of tons of hydrogen are converted into helium every single second. Not every star is born the same way, however. The amount of material collected during its birth determines almost everything about its future. Small stars burn their fuel slowly, glowing gently for hundreds of billions or even trillions of years. Medium-sized stars like our Sun enjoy relatively peaceful lives lasting around 10 billion years. But the true giants live very differently. Massive stars consume their fuel at astonishing speeds, burning hotter and brighter than millions of suns combined. Their lives are incredibly short on cosmic timescales, sometimes lasting only a few million years before meeting a violent end. Yet these giant stars play a crucial role in shaping the universe. Inside their cores, nuclear fusion creates heavier elements such as carbon, oxygen, silicon, and iron, the very ingredients that eventually become planets, oceans, and even living organisms. The next time you look up at the night sky, remember that those tiny points of light are not simply distant decorations. They are enormous nuclear furnaces, cosmic factories, and the architects of everything around us. Some are just being born. Others are nearing the end of their lives. And somewhere, hidden inside a dark cloud of gas drifting silently through space, gravity is already beginning the process again, creating the next generation of stars that may one day light up the universe. And perhaps even give birth to another world where someone else looks up and asks the very same question: where did the stars come from?